Example 4. For a pair of sample x and y values below, Part A, we want to identify the observed values. Part B, find the predicted values using the regression equation, where y is equal to 1 plus x. C, find the residuals for each observed predicted value. And D, find the sum of the squares of the residuals. So the first thing we want to do is we want to create a table, okay? And in this table, we're going to do the following. We're going to create one column that represents the observed values. Then we have a second column called the predicted values using this equation. Then we have the residuals. The residuals is taking the observed y value and then subtracting the predicted y value. And then once we find the residuals, we're going to find the sum of the squares of the residuals. So the first thing is, let's identify the observed values. So we're going to use these as ordered pairs. So we have 8, 4, which represents the observed value here. Then we have another observed value, 12, 24. Another observed value, 28. Another observed value, 24, 32. Okay. Now we want to find the predicted values. So that means we want to use this equation. So we're going to substitute the value of x into this equation. So if you take a look, we have the first value of x. First value of x is 8. So we're going to plug it into the equation. So 1 plus 8 is going to give us the predicted value of 9. Okay, next, the observed value 12, we're going to plug it into this equation. So then 1 plus 12 is then going to give us 13. Next, we're going to take the next observed x value, and that x is 20. So therefore, plugging it into this equation, 1 plus 20 gives us 21. And the last one, we're going to take the value of x to be 24. We plug 24 in for x, 1 plus 24 is equal to 25. Okay, so now what we're going to do is we want to find the residual. So we're going to take the observed y value, and then we're going to subtract the predicted y value. And it can be written the same way here. This observed y minus the predicted y value. So if we take a look at the first one, this represents the observed y value, and this value represents the predicted y value. So what we're going to do is find the residual. So we're going to take the value of 4 and then subtract 9, and 4 minus 9 gives us a residual of negative 5. Okay, the next one, we're going to take 24, which is the observed y value, and then we're going to subtract the predicted y value of 13. So 24 minus 13 gives us 11. Therefore, the residual for that one is 11. Next, we're going to take the observed y value of 8, and then we're going to subtract the predicted value of 21. And 8 minus 21 gives us a residual of negative 13. And then lastly, we're going to take the observed y value of 32, and then we're going to subtract the predicted value of 25, and then that equals 7. So again, if we come back up here, what is a residual? So if you recall, the residual is the difference between the observed sample value, right? And that's what that means. And it says here that it is based on vertical distance between the original points and the regression line. Okay, now in the last column, what we're going to do is we're going to take each one of these residuals and then square them. So if we take the value of negative 5 and square it, well, negative 5 gives us positive 25. Okay, if we take the next residual of 11, if we take 11 and square it, that gives us 121. The next residual, negative 13, if we take negative 13 and square it, that gives us 169. And then if we take the last residual of 7, 7 squared gives us 49. So now if we add up 25 plus 121 plus 169 plus 49, that's going to give us the sum of the squares residuals. That is the abbreviation. The sum of the squares of the residuals is equal to 25 plus 121 plus 169 plus 49, which equals 364. Okay, now that we have that information, now let's go ahead and graph this information. So what I mean by that is you want to go ahead and graph these points. So let's first go ahead and do that. We're going to graph our points. So let's go ahead and copy our points over here. And then on this graph, we're going to do the following. So we can see here that the x-axis, okay, is going to represent the x values, which is the x, and then this is y. So that's our x, and this is y. So we have 8, 4. So this point right here is going to represent 8, 4. Then we have 12, 24. So this point here is going to represent the ordered pair 12, 24. Then we have 28. So therefore this point is going to represent the ordered pair 20 and then 8. And then this ordered pair is going to represent the pair 24, 32. Okay? So now what we want to do is we want to take a look at the residuals. So let me go ahead and copy the residuals over here, and this is what we found in the table over here. Okay? Now I want you to notice here that we have our ordered pairs, and then we have this line that represents that regression line in the second column, which is the predicted values. And so this now, what we want to do is we want to take a look at the residual here of -5. So this represents the first ordered pair. Okay? So if I take this first ordered pair, okay, you're going to notice that we have the residual, which is -5. Okay, now again, this represents the ordered pair 8, 4. And you notice that we have the residual of -5. Okay, this represents the distance. So from this point, which is 8, 4, okay, this point here is on the line. So therefore, the distance is -5. So therefore, it is below that line, and we have a residual of -5. Okay, let's take a look at the next point, which is 12, 24. Okay, so if we take a look at 12, 24, okay, this is going to give us the following. It's going to give us the residual of 11, because you can see here that this point, 12, 24, okay, has a residual of 11. So from this line to that point, it's 11. Okay, next we have the point, the ordered pair 28. Okay, and the residual for that is -13. So here's our point 28. Okay, and then the residual is the following. The residual is -13, and that is the distance from this point to the regression line. Let's take a look at the next one here, 24, 32, and the residual is 7. So if we take a look at that one, we can see that the residual is 7, okay, and therefore the distance from that point to the line is 7. Okay, so how are we getting these distances? Well, we just saw that, right? And so if we wanted to, let's take a look at the points of the predicted y values. Okay, so for the predicted y values, we have 9. So that means that the predicted value for the y value of 9, that means that this point is right on the line, and that point represents 8, 9. Okay, the next predicted value is 13, and that means that this point right here represents 12 and the value of 13. Okay, if we take a look at the next predicted value of 21, then that means that this point right here is on the line, and that represents 20 and then 21. Okay, and then this point right here is going to have the predicted value of 25, and therefore that's going to be 2425. Okay, so I want you to take a look at this and what's happening here. Okay, when we plot these points on a line, this is what the line gives us. Okay, now if you take a look at the points that we got from the observed values, which is 8, 4, if we take 9, or if we take 4 and subtract 9 to get there, so it's below the line, that's how we get -5. That's the distance from here to here. Same thing over here. The distance from this point to this point is taking 8 subtracting 21 to give us -13. Okay, same thing with this point here. This is 12, 13. Now this point is above the line. So therefore 24 minus 13 gives us +11. So the distance from this point on the line to that point is 11. And then likewise with 24 and 25, there's that point. The actual observed value is 24, 32. 32 minus 25 gives us a residual of 7. So that's what that means, is the distance from the observed points to the predicted points on that line. Now, I also wanted to comment on the last column where it says the sum of the squares residuals. Well, that's why they make this square, right? So they make the square according to the residuals. Okay, so the sum of the squares residuals is the following. So if we take the square, meaning that if we want to find the area of this square, right? Or we want to find the area of this square, right? Or the area of this square. And the area of this square here. Okay, so what that means is, okay, if we take 11 and square it, that's how we got 121. If we take this residual of 7 and square it, that's how we get 49. And over here, if we take -13 and then square it, that gives us 169. And down over here, if we take -5 and then square it, and then we get 25. And therefore, when we add those areas, that's how we get the sum of the squares of the residuals. That means when we add these up, that's how it gives us those values.